Hello, everyone, and welcome to another virtual interaction session. And I'm extremely excited about today, specifically not just because we have somebody from one of the leading tech giants of the world, but also because Dr. Sriram Rajamani is somebody that I have been following very closely, and someone I hope we'll get a chance to bring across to Krea someday and look forward to a longer term association. So Dr. Sriram Rajamani, for everyone, on a quick introduction, is the distinguished scientist and managing director of Microsoft Research India. He is an ACM fellow, an INAE fellow. I did clarify with Gaurav what all of that meant, which was interesting. A position very reserved for the top 1% in the world.
It's very impressive.
No pressure on us. and the questions we are yet to ask you. He is the winner of the Computer Aided Verification Award. His work has impacted both academic and industrial practice in programming languages, systems security, and formal verification. He's currently working on combining program synthesis and machine learning. His first degree wasn't far from where we are at the engineering college in Guindy. And Dr. Rajamani went ahead to do his master's in sciences at the University of Virginia before his PhD at UC Berkeley. Quite coincidentally, I was also checking out today the 20 best recommended books for 2020 by Mr. Bill Gates, and did see Good Economics for Hard Times listed in that by Abhijit Banerjee and Esther Duflo, and there is a very strong Krea connection to both of them. So we already are starting off on a fantastic note of that connection through the organization, and we look forward to this going further. Thank you so much. We completely understand it's an extremely busy time for you, and for your team, and thanks for taking the time for us. Today, Dr. Rajamani, we have a slightly different format. He will be in conversation with Dr. Gaurav Raina, our very own head of Research Council, only because I will be sitting there asking for acronym expansions, and Gaurav is better placed to actually conduct this interview, both in terms of, the capability of this area and his knowledge. Thank you so much. So over to you, Gaurav, and we do look forward to the hour. Please, everybody, feel free to post your questions either in the Q&A section or in the chat section, and we'll take that at the end of the interaction between Gaurav and Sriram. Thank you so much, Sriram. Welcome again.
Thank you very much. I look forward to this. Thank you.
Yeah, thanks a lot, Kala. I know how hard it might have been to get somebody like Sriram, so sort of full kudos for that. And we are obviously extremely excited, Sriram, to have you over. Well, it'd be great to start with getting to know you a little bit personally, right? So it would be great if you could share one or two or a few sort of pivotal moments in your life that helped decide I'm going to research, or helped decide I'm going to do a PhD, or helped decide I'm going to go into technology. So what were those couple of sort of pivotal moments that have essentially helped shape who you are today?
Oh boy. So I don't, plan my life that much. I sort of take every day as it comes. So I don't think there was a lot of planning, but I can actually recall a few things that are very crucial for me, right? I did my undergrad, as Kala was saying, in Guindy Engineering College, and I had really good, mathematics teachers teaching me there, right? And even though I think in undergrad, my undergraduate degree in computer science, and a lot of, in undergraduate classes, right, everybody likes programming, which I also did, but I had really good discrete mathematics professors who taught me the mathematics behind computing. I had a really good professor, Professor T.R. Dhanapalan, and he used to have discussions about, computing existed even before computers existed. The notion of computing as a mathematical process actually predated digital computers. So, I had opportunity to learn from people who thought about computing as a mathematics, and I really fell in love with theoretical computer science when I was an undergrad. And so I did my undergraduate thesis with Professor Pandurangan, who's also an algorithms theory person at IIT Madras.
Indeed.
And I was really interested in the mathematics behind computing. So I think is what prompted me to go to the US and study further and so on. But I think for some strange reason, I took a break between my master's and my PhD, because after my master's, I decided that I've just been in school for too long. And I think I also wanted to buy a car, which seemed like a good idea at that time. So I thought maybe I should get a job and buy a car. So I bought one. Then, and I actually I actually became a programmer. I worked as a programmer for about 5 years, and I wrote a lot of code. And I think my interest in both being a practitioner and writing real world software. I also work for hardware companies, and having an interest in the mathematics behind computing. I think at some point the two of them came together. For a while they were just two different areas in my life. One I do to make a living and buy a car, and the other I do for my intellectual interest. And then at some point I sort of figured out that we can put them together, right? That I could actually do what I enjoy and also actually have a career doing that. So at that point, I actually thought that I actually worked on software verification, which is which is what I did my PhD thesis in, where you sort of think about programs as mathematical objects and try and prove properties about them, just like you would prove theorems in mathematics,
Sure,
right?
sure.
And then it occurred to me that actually you could do that not just for toy programs, you could do it for real world programs, which is actually what a lot of my work, professional work, was about. So I think I would say actually the realization is that the theory and the beauty of mathematics can actually combined with the scale and messiness of real world. I think I would say that was and I think the two don't have to be divorced from each other. So I would say
Sure.
that's
So how did you find yourself in Microsoft research in India?
Oh, so after I graduated, my PhD thesis was in hardware verification. So I sort of verified large microprocessors and so on. And then after I graduated, I got into some people who wanted to use these kinds of techniques to verify software, real world software. So that's why I joined Microsoft Research in Redmond, and I did a bunch of work there. In 1999 is when I joined Microsoft Research in Redmond, and I've done a lot of work there around how to apply these kinds of formal techniques to Microsoft software, to Windows, the operating system, to device drivers, and so on. And I was doing a lot of sort of this kind of work. And at some point, somebody told me, "Hey, do you know that we are actually opening a lab in India?" I was in Microsoft Research in Redmond. I've always wanted to come back. Around 2005, they opened a lab in India. And they asked me, would you like to go? And I said, yes. And I just moved here because I always wanted to come back. But, coming back with Microsoft Research means that I could keep the connections. I had great colleagues that I could keep in touch with them. And I just moved here without much of a plan. I just moved here because I thought I could continue to work with my colleagues. But then after I moved here, I realized that there are many interesting things you could learn when you are involved in setting up a lab from the very beginning. Right? Microsoft Research in Redmond, has hundreds of people, and this was we were like 3 or 4 people who came here to start this lab here. So that was a different experience in itself. And I moved as a researcher here. I mean, I didn't move as director. I was quite young, much younger than 15 years ago, and I was just doing technical work. And I actually never imagined I would head this lab also. That was not part of any plans. So at some point, I guess, over time, I also gathered breadth. I started understanding many other areas. I had a passion for advocacy, so I'd actually advocate for my colleagues' work. I would understand that. I could articulate other people's work well, because actually that was something that I enjoyed doing. And sort of that led to participation in research strategy. And at some point, actually, I guess the previous director left, and they needed somebody to run the lab. So they asked me to run it. So that's none of it was planned.
Right. So if I were to sort of say, can you articulate one reason that comes to mind immediately on why you get up and go to work? What's that? You mentioned numerous things, but one thing that.
Yeah, this one is very simple. It's my colleagues, it's my collaborators and the people we have at Microsoft Research in India. We have around 70 full-time people, and then we have around 50 students. We have these people called research fellows that spend 1 to 2 years. It's about 120 people, absolutely brilliant people. Many of them ACM fellows, INA fellows, SSB prize winners. We even have a MacArthur prize winner in there, who work in many different areas, ranging from theory to systems to machine learning. And just the sheer joy of just talking with them, that's what keeps me up. And students, right? We have this program called the Research Fellow Program, where young students spend 1 to 2 years with us, and our young people are fearless. So it's just very charming to see their fearlessness. So it has to be my colleagues. Yeah.
Right. Okay. So given that it is such an exciting place, obviously, could you sort of give us a sense of maybe one or two exciting research avenues that are happening in Microsoft Research India today?
Yeah, maybe I'll tell you two that actually I find absolutely fascinating. Both of them are very techy. So maybe explain, let me explain both of these things to you. The first one is actually a very interesting problem called nearest neighbor search. Let me just say what that is, right? And the context for this is actually how search engines are actually changing, right? Today, if you go to if you go to a search engine, right, and you type, Gaurav Raina or Sriram Rajamani, there is actually a technique that is called information retrieval that is actually being used. The search engine indexes all the documents in the world, and then it does a matching of what question you ask with all sort of the documents that are there, and it sort of retrieves what the relevant documents are using word similarity. How many occurrences does Gaurav have in the document, or Raina has in the document, right? And then it sort of matches the documents, and it sort of calculates which one is most likely to be relevant, and then it shows them.
Sure.
So this is how the search engines of the exteriors sort of work, but that's actually dramatically changing. If you look at how search engines of the future are going to work, right? It is actually based on something called embeddings, right? Called vector embeddings. So what happens is that there are, due to the advent of deep neural networks and so on, there is actually a notion called semantic embedding, as a result of which everything, queries as well as documents, are transformed into points in higher dimensional spaces. Something like, so both web pages as well as queries could be transformed into points in maybe 1,000 dimensional space, or even a 10,000 dimensional space, right? And then when somebody asks a query, what you do is actually you take the query and sort of index into that space. It sort of takes you into a point in this 10,000 dimensional space. And then you have to find what are all the documents that are in the geometric neighborhood of that space, right? It's sort of, you think about it in the three-dimensional space, the query might be here, and then you sort of like go around, find all the other things there, and you have to retrieve them, right? But you have to do this for, billions and billions and trillions of documents. How do you do that, right?
Sure.
So there's some people in my lab who are working on both the mathematics behind it and also the systems that are needed to make it work for 1 trillion documents, right?
Sure.
So how do you do that? So that's actually an example of something fascinating that's actually happening in our lab. It involves a combination of mathematics, as well as actually real world system building. Another one, which I think you might also find fascinating, is actually making machine learning work on very, very small devices. So it's the first one as an example of problem at scale.
Got it.
The other one, today, if you look at, there's this buzzword called IoT that everybody talks about, Internet of Things. People have these small chips. It could be sensors. You could have like a speaker in your home, and all of them now have computing ability. Your refrigerator has computing ability now, and what can you do, with those kinds of devices? And today, actually, if you look at how those things are connected and how they become intelligent, it's not the intelligence on the device itself. It's actually connection to the cloud that makes them intelligent, right? Like for example, if you have a Alexa speaker, the Alexa speaker works only if there's connectivity to the cloud. I mean, all that the speaker does is actually it transmits your voice to the cloud, and all the intelligence and the processing actually happens in the cloud. So we have some exciting projects in our lab where we are thinking about, can we actually make AI and machine learning work on those small chips? They only have really small amount of memory, and they use, even in cases where you do not have internet connectivity, right? So how do you do that? And then we have some really exciting algorithms on how to make machine learning algorithms work on such small chips. That would be another. So those would be two examples I would give.
So two examples. Sure. So those are examples of sort of things that would be of interest anywhere in the world. Given that you're based in Microsoft Research in India, it'd be nice to hear about an example or two of research that was inspired because you were based in India.
Right, and we have several. In fact, actually, Gaurav, right, the way our lab our lab has four focus areas. The focus areas are algorithms, which is sort of the mathematical basis behind all of computing. Then we have an area called AI and ML, which is everybody knows what that is these days. It's very popular. Then there is the third area called systems, which is sort of the science of actually building things. And there's a fourth area called technologies for emerging markets, which studies the role of technology in socio-economic development. So those are the four areas that we work in our lab, and the fourth area is very unique to our lab, right? And we're really inspired by sort of India as a test bed. And it's one of the most exciting areas, I think, because it's very unique to our lab. And that is an interdisciplinary area because that has both computer scientists as well as social scientists, ethnographers, who study people, who study communities, who study problems, and so on. And if you look at this area, a lot of the work that we do in this area is inspired by India. I can give you a few examples. So an example of something that we have done in this area, which I think has gotten a lot of traction, is tuberculosis medication adherence. So the context is that India, as you may know, is still, we've eradicated smallpox, but we have not eradicated TB. TB still infects millions of people and kills millions of people every year in India, for, much more than HIV, for example, or cholera, for example. Unlike COVID, at today's COVID time, the good thing about TB is caused by a bacterium. And there are actually antibiotics that can be used to cure TB. There are antibiotics that have been designed, but the duration of taking the antibiotics is very long. You have to take medication for 6 months in order to get yourself rid of TB, and that's a very difficult thing. Because the drugs have toxic side effects, and so and then particularly if you are dealing with a person who are maybe semi-literate, illiterate, lower down in maybe poor people, they might not even know that they have to actually continue the medication and do the entire regimen. So they might stop after 2 months or 3 months, and then they get something called drug-resistant TB, which is both fatal and contagious. It's going to kill them. It's going to kill everybody else that gets the TB from them because the bacteria has mutated. So the World Health Organization says that the only way to eradicate TB is that even, first of all, you have to diagnose people. That's a very important thing. But even after you diagnose people, you have to follow this protocol called DOTS. DOTS stands for Directly Observed Therapy, which means that a healthcare worker and the patient have to meet each other every day for 6 months. And the healthcare worker has to put a check mark saying, oh, this person. You can imagine how difficult and cumbersome it is for both parties to actually meet every day. So we have a project called 99 Dots. It was initiated by Bill Thies and Andrew Cross. And 99 dots is the goal is to have 99% of the efficiency of dots with 1% of the effort. That's why it's called 99 dots. And the goal is to use technology to figure out who's actually taking medication and who's not taking medication. So the healthcare worker can actually concentrate their effort on people who are not taking medication, and they don't have to actually go meet people that are taking medication anyway. So you want to use computer systems to get signals from who's taking medication and who's not taking medication. So how do you build a signaling system which is really low cost that tells us actually who's taking medication and who's not taking medication? And I think our lab, we designed many things. They designed many tech things, this kind of gadget, that kind of gadget, and none of them actually worked. What finally works is, we work with pill manufacturers and make a special envelope such that when the pill comes out, it exposes a number to which the patient is counseled to give a free call, right? And then a computer picks up the call on the other side and records that the call has come, right? Such a system is very inexpensive, but it's very hard to design because we don't know who has which envelope, and we can't put a different number. There are too many patients who have different phone numbers, right? So what we do is that we have about 20 phone numbers, and each envelope has a unique permutation of those 20 phone numbers. So one envelope might have phone number 1357, and the other one may have a different one. So, and then these are designed in a code. There's a computer science notion of a code. These are designed using a code. They have a property that once you know the 4 numbers, we can predict the remaining numbers with very high probability, right? And using these kinds of methods, we know which envelope everyone has. And as a result, when the call doesn't come, we know who is not actually calling.
Got it.
We can actually send somebody. And this project, right, it was designed. We have now spun this up into a startup. It's called Everwell Systems. It has served more than 250,000 patients in India, 250,000 patients in India. Um, it is part of Prime Minister Modi's Stop TB initiative. 6 states now have mandatory 99 dots as part of their program. It's funded by the Gates Foundation. It's funded by Stop TB. It's funded by WHO. I mean, it's a startup which has 35 people working on it. So that's kind of an example of something that was really inspired by India. I could give you a couple of other examples also if you're interested.
Sure, sure. So I guess what one has heard a lot from you is this sort of intersection at one level of computer science and mathematics, at another level, the intersection of theory with practice, at another level, intersection of what you're doing within a lab with the larger ecosystem that you're working in.
Right, absolutely.
And all of these are sort of, in some sense, different manifestations of sort of innovation, so to speak, right? And there's a lot of sort of buzz around innovation that one hears. What, in your opinion, or how would you define or have a shot at defining innovation in general? And the other question, I guess, which is a little bit more specific, is what do you think might be some of the necessary ingredients for innovation in technology?
Yeah. So I guess actually, one would think about invention as just inventing something really new. I guess the invention of the light bulb, I think Edison invented the light bulb. I think before that, I think nobody had a light bulb. I guess that was an invention. I think innovation is really more like tweaking, adapting, improving things. And in tech, actually, a lot of people talk about innovation all the time because we are actually now changing, adapting, reconfiguring materials in a slightly different way to have a different application or something like that. But innovation is still extremely important, right? It's extremely important. And it doesn't have to be incremental. It can be quite disruptive.
Sure.
And I would give an example of a really disruptive innovation, from a very tech-centered way, is this notion called virtualization,
Sure.
right? So, we all have, computers, and I'm talking to you with my laptop. My laptop has a processor, it has a CPU running it. And, my jobs are now using, my processes in my computer are using that hardware, right? But at some point, people thought that, maybe multiple jobs can use the same CPU, right? And each one can have its own virtual CPU. So I could have maybe, even though I have only one Intel processor in this machine, I could virtualize it. And I could actually run 5 different virtual machines. Each of them looks like its own computer, right? And this was not something that happened overnight. It was an innovation. It happened slowly, right? But I think this is what led to cloud computing, because the reason, the fact that you could actually virtualize means that you can have these big data centers, and you could actually virtualize the machines and move the jobs from one to another. Like if one computer fails, you can move them around, and you don't have to buy a physical machine. You can just schedule your job in any machine, and it will look the same. And you have economies of packing. With single physical processor, I can actually run hundreds of jobs, right? And I could get economies of scale. So that's sort of an example of something. Virtualization, I think, took 15, 20 years to build. But once it was built, right? I mean, it is the backbone behind cloud. So that would be kind of an example. So I think actually innovation, can be disruptive. It can be disruptive, and a lot of innovation actually tries to solve a real problem as well. So you asked me for ingredients that are actually needed for real disruptive innovation. I would think that you need, both the supply and the demand. The supply is actually, you need creative people who can think that way. And you also need a demand. You need to have real world problems sort of floating around that, in some sense, challenge these people. And you also need people with different skill sets, right? You need people with different disciplines working together to solve real world problems. So I would say those, I think, are the ingredients. Yeah.
Sure. Yeah. Thanks for that. Within talking of innovation, it really makes us think about the here and the now. The world is in turmoil. Every nation in the world is in turmoil. Every region is in turmoil. Um, It'd be great to get some thoughts from you on the sort of opportunities and the challenges for tech-based solutions, technology-based solutions, which could possibly have a rather large impact in India, and not just related to COVID, right? So not just related to testing or to anything around the disease, but the opportunity that you think you see about technology-based solutions for large-scale impact in India over the next 3, 5, 10 years, given that the world has really changed, is changing as we speak, and is going to keep changing for a while. I think the starting lines are being redrawn. When the starting lines are redrawn, there are new opportunities. So what, do you see any sort of new potential opportunities where you could have tech-based solutions having large-scale impact within, let's say, the context of India?
Yeah, it's a very interesting question. And of course, I think, to me, sort of the most immediate one is actually, the discovery of a vaccine and the discovery of a cure, I think, for which tech, I think, absolutely has such an important role to play. Most of drug design today is very interdisciplinary, work between, bio, health, as well as computing. But I think, if I just step back from that and sort of think about the larger context, right? Sort of to me, I think a very important thing is, like for example, I live in Bangalore, where the traffic is sort of maddening usually, right? And now they've removed the lockdown a little bit, and I go, the streets, are empty, the roads are empty, right? Even after a cure is discovered and everybody goes back, I wonder, should we just go back into that same traffic madness that we had before? Or, now that we sort of know that we can actually work like this and we have sort of gotten used to it, maybe actually we can do a combination of physically meeting with each other and also remote working, and it will be easier to enhance our communication infrastructure than enhance our physical infrastructure, which is actually so much going to be more expensive. And I think maybe the other thing is actually if it actually somebody else remarked actually to me. I was talking with somebody in Redmond, and somebody said actually these days, Sriram, I don't really differentiate between talking to you and talking to my colleague who's also in Redmond, because you guys both, I mean, there's a time zone difference, but they're also talking from their respective homes and to me. So it actually, I think, to me, the profound implication, it's probably going to matter less where you live. There is going to be, the virtual interactions are going to be a lot more. And some things we could think about as actually in India as a society, we have suffered from urbanization. Urbanization has caused, high densities of cities, severe constraints on, big cities. And at the same time, in villages and so on, there's actually population is depleting, right? I think sort of, probably a really big opportunity that India has is to de-urbanize, right? Have encouraged people to go live in, second tier, third tier cities and still have a career, right? And sort of think about, how computing systems can be designed in such a way that people can live and work wherever they are, right? And I think, use that to give economic opportunities to people, more different varieties of people. So to me, actually, that I think is a huge opportunity.
Yeah, sure. I mean, sort of true decentralization, so to speak.
Yeah.
Yeah, great. Now, it's of course very difficult to have someone like you and not ask you questions about AI. So, I mean, that's sort of, one of the things that's on everybody's mind. So if I were to just say artificial intelligence, great for humanity, scary, or both, and expand.
Yeah, I would go with both because I think it has both aspects to it, right? I mean, it is great because, I mean, who doesn't value a search engine? I mean, a search engine is actually at its very core, machine learning based. Who doesn't enjoy actually, being able to index and search anything that's present anywhere. The other things actually, are promises like, for example, because of AI, the computer can understand what you're talking, right? It can understand speech, it can actually understand natural language. This means that, people can talk to a computer, which means that more people can actually use the computer naturally. I think these are just enormous things that are going to continue to have profound changes actually in the way technology is built and being used. But I think that there are concerns, right? The advantages are actually, now that actually we can have, human-like interaction. We can have telemedicine. We can have computers scan X-rays first to identify which X-rays potential risks, and then a human can come in. I mean, the potential is just sort of immense, right? I would say I think the dangers are I don't actually think, I think when I was growing up, I used to see this movie called Terminator. Have you guys seen this Terminator movie? Where sort of Arnold Schwarzenegger comes in as like a robot and kills everyone. Yeah, I guess actually people think, whether, computers can become self-aware and, conquer the world. I don't believe that, because I think actually we are very far from that. We're very far from that. But what I do worry about is in our I guess, exuberance and optimism about technology. I think sometimes we might deploy AI solutions before they are ready, right? For example, in the West, there is a lot of effort in building self-driving cars. That's actually a really good, AI system. I think it's in my mind, there's a big question about how safe that is going to be, and whether we will be pushed to deploying those kinds of things before they are ready, right? And even simple things, right? You can easily build a toy for a child that can talk to the child, right? And actually answer some questions. But in our exuberance, if you sort of think about that, if you market that as a companion for a child, right? That is so dangerous, because the toy is going to answer, a few questions. And after that, it is going to become repetitive and boring, right? And if a parent now believes that, oh, now I have this toy that is intelligent, that is talking to the child, and it can even replace actually a human contact with a child, then you're, severely disadvantaging a child. So I sort of believe actually that, and I'll actually give you other examples, right? The other thing about AI that I worry about is that, a lot of supervised learning is very biased by our training data.
Correct.
Right? Like, for example, if you train a machine learning model based on, our current workforce, in a big tech company, which is predominantly male, right? And if you use that to actually predict where somebody else who's coming in is likely to be successful, that's going to be really biased by our training data.
You pick the male CV.
That's what's so. I worry about. I worry about, in sort of AI systems being put to stupid use, rather than a super intelligent Terminator coming and killing us. So that's sort of my that's sort of my concern.
Sure. So bringing AI sort of back home, you know, with Microsoft, you've had the experience of being in India, and you've also given us examples of how Microsoft research in India is doing, very cutting edge research work, and also research work which has been inspired by India. If we say made you the sort of architect for the AI roadmap for India, right? Saying, look, we don't have as much AI-based solutions in India at this point of time, let's say, as compared to the United States or in the West. And we might have had the opportunity to learn from, some of the things that haven't played out as well in the West. And so if you were to take a clean slate approach, and if you were in charge of architecting the AI roadmap for India, what should it be over the next 10 years or 10 years or 20 years? What would some of your suggestions be, or how do you go about thinking of something like that?
I see. I'm one of the things that has influenced me, I think, perhaps actually because of the way I sort of think about combining research and practice, is challenge problems. Right? I actually tend to think about science in terms of challenges. For example, if you look at ISRO is an organization in India that has been super successful over the years, right? Because the challenge of putting a satellite up there is something that everybody can understand. It's a very, very difficult thing to do. but it's something that everybody can understand. I think if everybody can understand what the challenge is, I think people will fail and try and again, and they will get there, right? I mean, that's one of the reasons why sort of the man on the moon vision that NASA had was also such inspirational. I would think that one of the things we should do in India is to sort of think about, challenges of what AI can do to people, right? So here's an example, right? 5 years from now, when the Prime Minister gives the Republic Day address, right, it should be simultaneously translated to 50 languages that everybody can understand, no matter what language. Maybe the Prime Minister speaks in Hindi. It should be translated into Gondi. It should be translated into the Adivasi language in the Uti, and it should happen live, right? And the Adivasi sitting in a hill should be able to talk back, ask a question in their tribal language, and then the Prime Minister should be able to answer back in Hindi. That to me is that can we build such a system, right, to do that? And I mean NLP is there. I mean, I think people can do that. People can translate between English and Chinese. People can translate between English and German. But can we actually really make our country in some sense language agnostic, so that anybody in the country can speak to anybody else, right? That would be an example of a challenge problem. Like, I'll give you another one. The other one I would give you is that I think in India, having talented healthcare professionals go to rural areas is always a very difficult problem. Rural India doesn't have quality healthcare, and it's difficult to actually have doctors go there and live there. It's because it's inconvenient to live there as well, right? Can I build a system where a city is able to adopt a certain perimeter around it and provide healthcare virtually, right? And and the people living in a rural area are able to receive high quality care by a combination of technology, and in some cases actually somebody has to travel. But that to me is actually can you actually build such a system? So I would actually the way I would, instead of sort of saying architecting this is how a system has to be built, I would actually start with
grand challenges, so to speak.
Grand challenges, so to speak, and have them be publicly visible, right?
So anybody can understand. So if you say the Prime Minister can speak to everybody, can speak to everybody else, that's a problem statement that everybody can understand. But
right.
You need to do it in a personalized manner at scale. That's, of course, then you obviously need to have linguists working with NLP folks working with it.
Yeah, absolutely. And also, with, human computer interaction people, and actually, and the way the government should fund it is actually, organize competitions, pick, first 10 teams and give them, 2 crores and let them run for 6 months, and then let them do demonstrations of what they've done. And then maybe 3 teams get picked, and then we pay them 3 crores. And sort of, I would actually think like that.
Sure. So that obviously, so when you're looking at, so now if you think about sort of solving big problems of which, let's say, AI is a part, or technology is a part, or innovation is a part. I mean, one of the themes that seems to be coming out very strongly in the interaction with you, Sriram, is obviously the notion of collaboration, right? You've talked about people with different skill sets collaborating. And of course, if you throw these grand challenges, then these grand challenges will spread all the way from the abstract all the way to the practical. And so if you look at these 2 different ecosystems that we have, one is academia and one is industry, right? There are certain modes of interaction that happen between academia and industry. It'd be great to get your sense of what are the kind of modes, that non-traditional modes of engagement that you think possibly have not been explored as yet. That's part 1. So if you had a clean slate and say, why don't you try this as an experiment, right? As a mode of collaboration between academia and industry. And of course, Microsoft and Microsoft Research do engage a lot with academia as well. In your opinion, what really works?
Actually, Gaurav, right before I answer that question, one thing I must say is that I find, actually, I did my PhD at Berkeley, and I lived in the Silicon Valley for many years. I think I know, if I look at the universities in the Bay Area, like a Berkeley or a Stanford, the interaction they have with the industry is so much more than interactions I see between academia and industry in India. I sort of see, somebody would do a PhD or a master's. An idea would come up, and they would spin off a startup. The startup would become a company, and there would be some tie with the university, and the university would produce some open source software that everybody would suddenly use. Like Unix was actually designed at Berkeley. It's called BSD. The BSD distribution was actually defined. People would put out stuff, and then everybody would sort of use it. I think there is much more we can do, even by learning from other ecosystems, on how academia and industry can be close to each other. But in India, I find that they are much more separate than what we see in other countries. So I think some non-traditional things we could try are, maybe we could circulate people out. Maybe we could have professors from academia go spend 1 or 2 years. And maybe we could actually get people from industry to come live in a university and teach for 1 or 2 years and sort of understand these things kind of a little better. We could do things like, for example, when somebody does projects, those don't have to be academic projects. Somehow we should figure out how those can be actually real world problems, with industry mentors and so on, so that people on both sides gets their hands and feet dirty by working together. So it's a difficult thing to do. The reason why it's very difficult, I think it's difficult from both sides, right? I think most people in industry are constantly busy. So, it'll be hard to get someone to actually commit to doing that. That's a hard thing. The second thing is actually, even if they commit to doing that, they have to take the time to frame and abstract the problem in such a way that somebody else can actually understand it, right? Without all the context actually in their company. So that's actually a difficult thing to do. So there are many, many challenges, I think, in doing what I'm saying. But I think, universities like Krea, you are trying to do something different. Maybe, if you sort of think ground up, having sort of incubators, entrepreneurial things, having companies come out of the university and having tighter connections and having this feedback loop between industry and academia. Maybe, as you think about that, maybe you could try. I mean, many things will fail, but I think, if you try, maybe we will find things that actually work. But I think the key is people. You need to get people circulating. You can't have people stay in the one place. Yeah.
True. So what I'd like to do is sort of end with a slightly more abstract question, zooming out of all of this, right? You've talked about people, all the things that you've talked about so far. If you were to try and sort of reduce it into a little 2x2 matrix, really condense it down. So the elements of it are the individual and the collective. Mm-hmm. And another element is, new forms of knowledge, new forms of inquiry and impact, more societal impact, right? So you've got the individual, you've got the collective, you've got the notion of just trying to find new forms of knowledge for the joy of finding new forms of knowledge with no application in mind, but, we all hear that, if something is beautiful and elegant, it will eventually find some application. But on the other hand, there's also the notion of we should try and find solutions on a more shorter time scale, and you don't have to come up with, very esoteric theories to have, wide-scale societal impact. Your thoughts on how one might nurture such an environment where the individual, aspirations of proving theorems, of doing something interesting, feeds into the collective, and then partly, let's say, works towards the goal of just new frontiers of knowledge, but at the same time, also trying to have some immediate, relatively short-term societal impact.
Yeah, this is a question actually, we consider, this is a very interesting question. We considered one form of this question even inside Microsoft Research, right? It's a very important question. I think the question you're asking, the way I sort of think about it, is that there's a 2x2 matrix I can do, right?
Correct.
On the one axis is discovery of new knowledge.
Correct.
Right? Am I using existing knowledge, or am I discovering new knowledge? Am I discovering more beauty, right?
Sure.
And the other one is actually, am I actually solving a practical problem? Am I having impact around me? right? And then you can create this 4 by 4 matrix, right? And actually, on the y-axis, I could have existing knowledge and new knowledge, and on the x-axis, I could have no practical impact on actually solving a real-world problem. So you
Sure.
have these 4 by
Sure.
4. Of course, one quadrant is very uninteresting, which neither creates new knowledge nor have practical applications. But I can tell you that that quadrant is non-empty.
Correct.
So there's a lot of people who do that kind of work too. you know, but the other 3 quadrants actually are interesting, right?
Correct.
And my view is that you need to have a mix of all those 3, right? You need beauty without applications today. Those
Sure.
are super important, right? Because they are so important for science.
Sure.
You need actually areas where you are inventing, you are actually not discovering any new knowledge.
Sure.
But with existing knowledge, you are solving real practical problems. I think we
Sure.
really need to respect that. And
Sure.
I find that in Indian academia, there is not respected at all. Because
Right.
what is that is new? And I think that's actually
Sure.
something we need to change in Indian academia. Because
Sure.
actually taking existing ideas and actually making them work is super
Making the work.
important. It's super
Absolutely.
important, right? And then you
Absolutely.
have this interesting quadrant, which is up there, in which you're doing both. You are
Sure.
both discovering something new, and you are making something practical. That's like a jackpot. It's very
Sure.
few
Sure.
times
Sure.
in your
Sure.
life you hit
Sure.
that. I've been fortunate to hit it once or twice, right?
Right.
A small way. But you need to have an ecosystem where you have all those 3, and then you respect all those 3 things, and then you give encouragement to all those 3, and then people move between those things. Sometimes actually people start out in this quadrant and they move to the other one.
Sure.
And
Sure. Sure.
you need to have that actually that flow.
Anyway, from my end, this has been absolutely fascinating, and I can go on and on and on asking questions. But I shouldn't be selfish. I need to back off. There are numerous questions that have come up in the chat room. So from my end, it was just absolutely fascinating and a
Thank
pleasure.
you.
And I'll leave it to Kala now to sort of moderate the remaining bit of the session.
Thank you. Thank you both. Yes, the moment Gaurav mentioned AI, I knew this was going to take another 10 minutes. I was very confident about it, something he's very passionate about. And each of those questions would create, a session on their own. So thank you so much for patiently running through that. We do have a few questions in the Q&A and the chat box. So I'm going to start segregating a bit around, grouping a couple of them. We had a couple of questions, and this comes from Asta. It also comes from a couple of our students around the ethics, the role of ethics in AI, this whole space of role of ethics. How do you see that, this whole digital sovereignty in some sense, how does all of that get protected? How do you see that role beyond just the socio and economic implications of the application of AI?
Yeah. So I think, this is, when I think Gaurav, you asked me about, is AI good or bad or both, right? I should have mentioned actually, this is actually another worry of mine, where a lot of machine learning, I think AI it feeds on people's data. That's how we do them. And I think we collect them. I think if you're not careful about them, it can have, very serious consequences of, people's rights, people's privacy. You can have very serious consequences. I think actually what we need is, we need ways by which, we give people control over their data, right? And today we do, right? Today you download an app. The app tells you many, many things. Can I do this? Can I do that? And everybody say yes, yes, yes. I think that's the real problem. The real problem, I think, is that you can design, user license agreements. We call these EULAs, which say, I will use your phone, I will use your location history, I will do this. People are just going to say yes, yes, yes. I think, I think the real difficulty, I think, is that, what we need is that even if somebody gives you permission to use your data, there has to be, I think, a society has to have, just like there are courts, there has to be people that have both technical, non-technical representatives from both, government as well as actually civic bodies, right? Who sit there and they write like norms of actually how people have to use it. Like, for example, Europe has actually GDPR. I think India now, I think, has a data protection bill. and so on. I think we really need those kinds of conversations where we really need to have informed conversations about, what use of data makes sense, what use of data does not make sense. Now actually in the current COVID situation, right? Maybe actually we need to go out on a limb and collect more data in order to have public good. But that cannot be indefinite, right? So those kinds of social contracts have to keep changing, right? And we really need to have bodies that we need to design that govern those social contracts, and we should be fully expecting them to change with time. This is not something we're going to figure out in one go, but we have to try and change and so on. And that's a difficult thing. That's a difficult thing, I would think. Yeah.
Thank you. We are an academic institution, so this question comes, quite obviously. Professor Hariharan actually has hinted around, what do you see the role of whether that's machine learning or machine intelligence in the 21st century education? Are we adopting enough? What more could we do? Because his impression is we may not be adopting enough, but how are we, if we are going to look at an education for 4.0, in your mind, what could be some of the primary drivers for the 21st century education?
Yeah, I think, I don't think we are using technology enough, because I think actually in any, I teach also, so I sometimes teach. I find that in any classroom I go to, there are some students who completely get what I'm saying, and they'll be fine without me. I actually don't even have to teach; they are going to be fine. And there's going to be some students who actually are completely lost, right? I am actually serving neither population well as a teacher, right? I think actually making learning personalized, having people sort of engage with content according to their needs. I think, having these things like flipped classroom where people study, they watch lectures at home, and when they come and meet, I think, there's just discussion and there's real engagement that is actually happening instead of just, somebody sort of lecturing. People doing stuff with their hands, doing stuff together. I think that would be so much more fun, right? So much more fun. I mean, right now, right? We are just engaging via Zoom. I guess it's okay, but after all this COVID goes away, and suppose we are all together. Suppose that experience is the same as this current experience, right? Then we are doing something wrong, right? We are not making use of our presence together, right? So that's how I would think about it, but I don't know the solution.
Yeah.
But I think we are not using technology enough, I think. Yeah.
Just staying in that academic realm, because this came very early from Pratmesh, and he asks about what is to be taught in undergraduate education, and if you see there's value in courses like type theory and COQ or lean to be included in undergraduate education, and what kind of role do you envision for verified systems in the future?
But actually, I'm very biased. I actually find them beautiful. That's my research area. But I would think actually, I wouldn't make those compulsory courses, because some people, may not be interested in type theory and so on. I would actually see, more than verified systems, I think I would want undergrads to know that, programs are mathematical things. They are not, something that you write to make money. I mean, you can make money with them too, but they're very beautiful mathematical things. I would like students to know that. And I would like to, and people that are so inclined to understand the mathematics behind programming, the type theory, COC, and all those kinds of things. I think there should be electives where people go. One of the nice things I liked about the US is that even if you're an undergrad, right, if you're really interested in something, you could take grad classes, right? You could specialize. I think you should have a more flexible curriculum where those kinds of things, actually people who want to study them. That's how I would think about it. Yeah.
The next question comes from one of our MBA students, and don't know how comfortable you are in this space, but it's about asking, what are the disruptive technologies you see in the financial sector? Is that something that you're comfortable looking at?
I don't know much about finance, but I can tell you this, right? One thing I can tell you is that everything is becoming an algorithm, I will first, have a disclaimer that I have no background in finance, right? But I do know that many things like trading and, how to do investments are now being increasingly done by machine learning, right? And I have a lot of friends who actually do, computational finance and so on. So I think I wouldn't be surprised if actually in a few years in this country, insurance and many sort of risk-based businesses, risk-based products, the way we give loans and so on are extremely influenced by computing. It's already there in the West, and it's only clear that I think India is going to go that way too. Yeah.
Great. So we do have time for one last question to squeeze in. It comes from Abhinet. How do you look at the future of innovation? Is it more likely to happen where there is intersection of more fields or within fields? Because his impression is saving the technology space, whether it's traditional business like hotels and or restaurants, it seems to be saturating, even startups. So do you see them as an intersection?
So you broke up a little bit. So you're saying—
I'm sorry. Yeah. Do you see innovation more happening at the cross section of two fields, or do you see them happening in a specific field?
I think both, right? I think both are going to happen. I think more applications are going to happen at the intersection, and more foundational discoveries are going to continue happening, in individual fields as well as intersections. So I think both are going to exist. The both have always existed.
Fantastic. We are right up on time. So thank you so much. If there aren't any more questions, whatever was good, because the larger bulk of the questions were around data security and those laws. So it was great to have some of that, and the role of AR and VR, which you kind of put through in that example with the health, which was a great example of how we are going to use some of the AI and VR technologies as well, through that. So we're up with your time. So thank you so much for the last 1 hour. As I said, this is not going to be the end of your association with Krea. We'll make sure that we're going to drag you a little bit more into the work we do. And you've already planted a few exciting ideas in Gaurav's head about, how academia and industry can work together. So we'll kind of start experimentation from you. But thank you so much. And I will definitely share your podcast as well. I love to hear some of your stories, only because it's a fantastic storyteller, and got a chance to actually see that live today from you as well. So thank you, Sriram. Thanks for joining. Gaurav, some words of thanks from you.
Well, thank you so much. And this is not the last you're going to see of us.
Thank you so much. I think it's very enjoyable. I look forward to engaging with all of you as well. Bye-bye.
Thank you. Thank you.
Bye.
Thank you, everyone, for joining.
Bye.